DNS Resolution. Although we've already talked about DNS resolution in detail in this series of videos, mostly from the server's perspective, let's take a look at DNS resolution from a client's perspective. So suppose we have a user that's attempting to visit the winstructor.com website for the first time. Now currently, it doesn't have any knowledge of the IP address of the Winstructor web server, so it can't go straight there until it successfully locates the IP address of the web server. So the first thing the client's going to do is to check a local text file on its hard drive called the host file. Now this file is simply an ASCII text file that stores only A or host records. If the address for the Winstructor website is found, the client will go to the website directly, and that's the end of DNS resolution. So if we click on Start and open up our computer here and go to our C drive, the host file can be found inside our Windows directory, and we'll scroll down and select our System32 directory, the drivers directory, etc, and then the host file. Now we can simply open up this file with Notepad as it is a text file, and here we can just see a couple of entries, and that's for our local host. So if we wanted to add an entry for winstructor.com, we could simply type in an IP address and then www.winstructor.com. Now once we save this file, this will certainly make sure that our client can find www.winstructor.com, but what if the IP address of the Winstructor website changes? Well, in that event, you can be sure that you won't be going to the correct place, unless of course you come back into this file and update it with the correct address. But who wants to do that for every website or computer that you need access to? Well, believe it or not, many years ago that's what people had to do until DNS came on the scene. Now, as a side note here, you can actually enter in information into your host file that's not technically correct. So, for example here, I could type the real IP address of the winstructor.com website, and next to it, I could alter the website name and we could enter in something like Microsoft.com, and this means that users on this machine attempting to connect to Microsoft.com would in fact be directed to the Winstructor website. So be careful when writing entries into the host file, as it overrides all other mechanisms of resolving names to IP addresses, at least as far as this client's concerned. Now in the event that the address isn't found in the host file, which is likely since you probably won't be updating this file, then the client will check its local DNS cache to see if it has the address there. Now this only happens for Windows 2000, XP, Vista, 2003 or 2008 operating systems. If the computer is running Windows 95, 98 or NT, it'll go straight to the DNS server. But as this video is concentrating on Windows 2008, we'll stick to discussing DNS resolution for Windows 2008. Now a DNS client will cache a name and IP address, and each entry will have a time to live, or TTL, in seconds. This means that the client will keep a copy of this record in its cache for a certain amount of time. Now when this time expires, the record in the cache will be deleted and the client will have to look it up again. Now a quick point I should really bring up about caching: it's quite logical to associate caching with successful DNS resolution. But consider this. Let's say you've just built a new server and you've called it fileserver.winstructorlab.com, and you log onto your client machine and you ping the server. But it fails to respond. So you go over to the file server and you realize that you've configured the machine with an incorrectly spelt hostname. So you correct this hostname and you reboot the server. And you go back to your client and you try to ping the server again, and you get the same failed message. Why? Well, this is the result of negative caching. When your client caches addresses, it caches both successes and failures. When we tried to ping fileserver.winstructorlab.com, it failed, so our client cached that failure locally. Now when the problem's rectified, you again attempt to ping the server. Your client checks its cache and it finds an entry there. This entry says the hostname doesn't exist and the ping fails without actually having been attempted. Now you can verify what DNS entries your computer has cached locally by typing ipconfig/displaydns at a command prompt. So to solve this problem, we've got three solutions, although really only one of them is practical. The first thing we could do is we could add a host file entry, and this would indeed solve the problem, as our host file would be checked before the cache, and this entry would allow us to ping the host. And I'll also point out when we use this method and successfully ping the server, our local cache will be updated and future resolution will in fact work even if we go and remove the host file entry. Now, whilst this host file entry option will work, it's certainly not a desirable solution for reasons that we've mentioned earlier. The second option is to wait until the time to live on the cache record is up and the record expires, and then it will be deleted from our cache. Now sure, this will work too, but who wants to sit there and wait, especially if you need to access this server now? So our final option is to open up a command prompt and run the ipconfig/flush DNS command. Now this is going to clear out the client DNS cache, and now when we ping the file server, our ping succeeds. A final note here though, when you clear the DNS cache on your client using the ipconfig/flush DNS command, if you run the ipconfig/display DNS command immediately afterwards, you'll notice that there's still some entries listed, and these entries are whatever entries are in your host file. Okay, so after the client checks the host file and then its local cache, it then contacts the DNS server on UDP port 53, and it asks it for help by sending it a DNS query. Now in that request for help, the client also sends the DNS server a port to send the response back on. So the DNS server checks its cache. If it finds a match, it sends the reply back to the client on the requested port. However, if the DNS server doesn't have the information cached, it checks the name against its zones. Now a zone is simply a portion of a contiguous namespace in which a server has been given authority over, such as winstructor.com. Now, you wouldn't expect to have a zone on your DNS server for winstructor.com, although you certainly could. So unless this request is for a host inside your own domain, it's unlikely that the answer will be found on your DNS server. So if the zones do not contain the required information, the DNS server attempts to contact the DNS server that is authoritative for the winstructor.com domain. Now, as it doesn't know the IP address of the DNS server for winstructor.com, it's going to attempt to contact the next best thing, which is its parent. Now, assuming that this is a new DNS server that hasn't resolved any addresses at this point, it doesn't even know the IP addresses of the .com servers. So, it checks its root hints file for the IP addresses of the root DNS servers, and then it attempts to contact them. The root DNS servers don't know the IP addresses of winstructor.com, but they do know other servers that may know. So, it's going to send back the IP addresses of the DNS servers that are authoritative for the .com domain. So our DNS server now can send a direct request to these .com DNS servers. Now these .com DNS servers don't know the IP address of the web server on the Winstructor domain, but they do know who should know this information. That's the DNS server that's authoritative for winstructor.com. So they'll send back the IP address of the winstructor.com DNS server to our DNS server. Our DNS server contacts the winstructor.com DNS server and asks it for the IP address of the machine name www on the winstructor.com domain. The winstructor.com DNS server will respond, and it will send our DNS server the IP address of the web server, which our DNS server caches locally. Our DNS server forwards this information back to the client on the requested port, and now our client can contact the winstructor.com web server directly, and then retrieve the page. In this video, you've seen how DNS works from a DNS client's perspective. Now that you know how it works, it's easy to quickly identify if it's a client problem or a server problem that you might be experiencing. We hope you've enjoyed this video and would like to thank you for supporting Winstructor.